Alright guys, so we are talking about June 2017 today, and let's get into it. We are in the paper 2. Now, using a calculator or otherwise, so you can definitely use your calculator. It's a calculator exercise. Calculate the exact value of, you notice they use the word exact. We'll see why they use the word exact in a moment, right? So you could tell here, and just be careful because sometimes the print makes that look like an addition sign, but it is indeed a division sign, so be careful with that stuff. On the calculator, I would actually be using this button, A over B. You'll see it looking like that, just not B over C, sorry, and it'll be like that. So when I press the button now, you'll actually get, if I press 4 and press the button 3, you'll get 4 over 3. And of course, if I wanted to write a mixed number, like 4 and 3 over 2, it would look like this. Right? So just in case you don't like to use the calculator, because it's important to know how to work the fractions, I would actually use the brackets on my calculator. So I would press open brackets, 4 1/3, press minus 1 2 over 5, close those brackets. Then I would put divide, and for this guy, just to be safe, I would actually use just another bracket. Yeah, and I would actually use that. I love to use brackets on a calculator. It's super safe. It prevents you from making mistakes. So now you know that the calculator has a proper idea of what you're asking for. And what you'll end up getting is you'll actually end up getting a nice, solid, even answer of 11. So this question is definitely meant to test your calculator skills. Right? Now, in terms of when they said calculate the exact value, that means that they would prefer your answer in a fraction rather than a decimal, right? So instead of putting 0.3333, you would definitely be expected to put a third, and that is more of an accurate answer. Yeah. So here again we have another calculator question. What we're gonna do is we're gonna put open brackets 3.1 minus 1.15, close brackets, and then I'll square it. And to square it is you have this x squared button there, so you just press that, and what you should see on the calculator, you should probably see something like this, and that's how you know that it's been squared. And then I will press divided by, and I'm safe with this divide sign because everything here is in brackets, right? If you didn't put the brackets, the calculator would have probably just squared this and it would have gotten a wrong answer. So brackets on a calculator is incredibly important, and I'll use brackets again here for the denominator just to be safe. And the answer that I would get here is 760.5. Nice. So a store is promoting a new mobile phone under 2 plans, Plan A and Plan B. The plans are advertised as shown in the table below. So we could see here that we have plans, and it looks like a hire purchase kind of question here, because we have to, if we go in under Plan A, we'll have to make a deposit, then we'll have to pay monthly installments, and we'll have to pay monthly installments for 12 months with 0 tax. But you can see over here we have 5% tax on the total, 5% tax on all payments, not each payment but all payments, right? So Calculate the total cost of the phone under Plan A. Well, under Plan A, I would have to pay my deposit of $400, right, plus a monthly installment of $65 for 12 months and 0% tax, and that'll give me roughly about $1,180. Determine which of the two plans, A or B, is the better deal. Justify your answer. Well, I guess I'm going to have to find the total cost of Plan B. And Plan B is 6 months. So let's see how that goes, right? So we have a deposit of $600 plus $80 for 6 months. Supposed to be a multiplier, so $80 times 6 months, and then we would have to find the 6% or 5% of that total there. So let's find this total first. So that total is $1,080. But then we would have to find 5% of $1,080. So 5% being multiplied by $1,080 gives us about $54. So therefore, the total cost of Plan B, right, would be $1,080 plus $54, which we end up getting $1,134. So we could see here that Plan A is $1,180. Plan B is $1,134. So Plan A, $1,180. Plan B, $1,134. So therefore, Plan B is the better deal. John's monthly electricity bill is based on the number of kilowatt hour of electricity that he consumes for that month. So so his monthly electricity bill is based on the number of kilowatt hours that he consumes, right? So he is charged $5, and I'll just put that information on the side there, $5.10 per kilowatt hour. For the month of March 2016, 2 meter readings are displayed in the table below. So the beginning of March, and we have the end of March, and we have these meter readings here. That's interesting, right? Calculate the total number that John pays for electricity consumption for the month of March 2016. So for the month of March 2016, right, we have here readings in kilowatt hours. So we can see here that, and one thing I don't like about this question is how they spaced this. It gives you the idea that maybe these might be different numbers, but no, they're not. It's actually just one number. So at the beginning of March, he used 3,011 kilowatt hours, and at the end of March he used 3,307. So that means that total kilowatt hours that he used during the month of March would have been the 3307 minus the 3011, and that gives us 297 kilowatt hours. So if he used that and he has to pay $5.10 per, so that would mean therefore his bill is the total amount that John pays, right? So total paid would be the 297 multiplied by 510, and that would give us $1,509.60. For the next month of April, John pays that amount for electricity consumption. Determine his meter reading at the end of April. Wow, that is an interesting question. So at the ending of March, his meter reading is 3307, right? So at the end of March, we have 3307 is his meter reading, right? And well, we know for 297 kilowatt hours will cost this amount of money. So I'm just gonna put everything that I know. So for 297 kilowatt hours costs $1509.60. So costs $1509.60. Right. So determining his. So we know that at the end of April, he pays 2351. So we can actually find out, well, all right, if 297 is equal to 1509.60, then 1 kilowatt hour is 510, right? No, not 510, $5.10, right? So we can say that $1 will be 1 kilowatt hour over 5.10, and therefore if he paid $23.51, that would be $23.51 divided by 5.10, and this is actually the final thing. So that means that and it's actually 2351.10 divided by 5.10. That means that he used 461 kilowatt hours. So therefore, how much would the meter show at the end of April? So therefore, we will have his meter at the end of that was 3307 plus the 461, and that would give us 303768. And remember, the meter used a 5-digit thing, and if you forgot the 0, I don't think you would lose the marks for it. It's fine. Alright, so factorize the following expressions completely. So at the end of the day, when it comes to this question here, we need to look at what we have in common. We could see that 6 is in common with both of these terms. You have two numbers, this one and this one. 6 is a factor and y is a factor. So if I pull out 6y, I have to multiply by y to give me 6y squared minus 3x. So 6 3s are 18xy, and this will be your factorization for this question. 4m squared minus 1, this is actually a difference of two squares, and you have to know how to recognize the difference of two squares, and they do love to ask this question. So a difference of two squares is when you actually have a squared minus b squared, right? That could easily be a plus b into a minus b, right? So a difference of two squares, a squared minus b squared, is really just a plus b into a minus b. And so we can see here that this is of the form a squared minus b squared. So you can see b squared, well, b is 1, right? So that would be 1 squared is 1. 1 squared would give us 1. And then a squared, well, what squared will give us 4m? 4m squared. And you notice the m that's squared here, but this 4 is also just could be seen as 2 squared, so it'll be 2m. So if I square 2m, I would actually get 4m squared, because it would be 2 squared by m squared. So therefore I have my a and my b, so now I could just simply say, well, it's a, which is 2m, plus b into a minus b. Oh, I put minus b is minus 1, so. Alright, so we can see here we have a factorization question, and what we need to ask ourselves, well, we can see here this is a, b, and c, and the value of a is greater than 1. So if the value of a is greater than 1, that means that we have a different sort of procedure to do. So what we'll have to do here is we'll have to find two numbers that when I add them, I will get this middle number here, which is negative 3. And when I multiply them, I will get 2 multiplied by negative 2 is negative 4. So what two numbers that when I add them, I'll get negative 3, and when I multiply them, I'll get negative 4. So how about negative 4 and plus 1? So negative 4 plus 1 is negative 3, and negative 4 multiplied by 1 is negative 4. So we have our two numbers there. What we do is we take the two numbers and we substitute the middle number for them. So I'm seeing here that I'll have 2t squared minus 4t plus 1t minus 2. Right? So now that we did that, we will start to factorize, and we'll factorize this side first. We see that we have this, how we split the 2 here. And you notice I put the 4 on this side because I know that 4 and 2 have something in common. They are multiples, so they might be able to factorize a lot better. Right? So on this side, I am seeing here that I have t minus 2, and there isn't anything I could really do to factorize that. So I'm just going to leave that as t minus 2, right? And on this side, I'm going to need to get t minus 2, right? So in order to get t minus 2, I'll probably need to put 2t on the outside here. So 2t times t is 2t squared, and 2t times 2 gives us negative 4t, or negative 2, right? Remember, we actually have a 1 on the outside of these brackets here. So the factors we'll end up getting would be t minus 2, and we have 2t plus 1. Write as a single fraction and simplify. So we know how to minus fractions. It's the same as in common entrance exam. So we go 4 3s are 12, and then we cross multiply. So this will be 4 into 5p plus 2. So we multiplied that, and then we minus, and then we multiply that, 3p, well, I'll put the 3 in front of it. 3 multiplied by 3p minus 1. So now we just try to, let's see if we could just expand. We'll have 5 4 times 5 is 20p, and 4 2s are 8, minus 3 3s are 9p, right? And that'll be plus 3 all over 12. Yeah. And so what are we gonna have now? Well, 20 minus 9, that gives me 11p. Yeah. And 8, 9, 10, 11, that'll be plus 11 all over 12. And we could see here that this top number, I could actually factorize that. I could pull the 11 outside and have p plus 1 on the inside, and over 12. And of course, I could even write it as 11 over 12 p plus 1. If you leave it like this, that's no problem. Even if you left it like this, it's no problem. But at the end of the day, it's really good manners in maths too, because they say simplify. So we want to get an answer as simple as possible. So it's always good manners to factorize whenever you need to. So this here is obviously the simplest version of the answer that you could get. But so you'll definitely get all your marks with this one, but this one is just taking it the next step and having it as the simplest answer possible, right? A formula is given as d, which is equal to the square root of 4h over 5. So determine the value of d when h is 29. Give your answer correct to 3 significant figures. Well, this is a simple substitution, so d will be equal to the square root of 4 times 29 all over 5. So that gives us, let's go 4 times 29 first, divided by 5, and that gives us 23.2. So d is the square root of 23.2, and that gives us about 4.82, and that will be 3 significant figures there. Make h the subject of the formula. So we have, what is it, 4h over 5. So d is equal to the square root of 4h over 5. We've done tons of these in class. So first, well, since we're making h the subject, let's flip it first. So 4h over 5 is equal to d. I always just like to do that to have h on this side of the equation. We actually didn't change anything there, but we're about to, because now we can get rid of this by squaring both sides. So we'll just have 4h over 5 is equal to d squared. And now we can see here that if we throw across the 5, it's going to be multiplied by 5. And if we throw across this 4, it's going to be divided by 4. So we can actually see that h is multiplied by 5d squared divided by 4. And we can actually simplify this to say 5 on 4d squared. The universal set U is defined as the following, and of course this is written in the algebraic form, so we need to be able to read that the universal set is the set of numbers such that those are natural numbers between 2 and 12. So natural numbers between 2 and 12, and you notice it does not include 2 and 12, so it would be 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are the numbers we're dealing with there. The sets M and R are subsets of U such that M, we have the odd numbers in M, and we have R being the square numbers, okay? So list the members of the set M. So we have the set U over here, so the set M will be the odd numbers, 3, 5, or the set of 3, 5, 7, 9, and 11. right? And of course the square numbers, and let's just bring this down here so I don't have to keep scrolling up. So the square numbers out of the set would be the numbers 4. So R is the set of square numbers. 4, 5 is not a square, 6 is not a square, 7 is not a square, 8 is not a square, 9 is a square, 3 3s are 9, right? 10 and not 11, no. So we have the numbers 4 and 9, and those are the square numbers. Draw a Venn diagram that represents the relationship among the defined sets. So this Venn diagram, well, we know we have, do we have any intersection, first of all, between R and M? And yes, we do have one number, the number 9. So yes, R does intersect M, and that tells us how to draw our Venn diagram. We have U here, U, and then we have M, and we know that M and R intersect, and we have 9 in there. Let's call this M, let's call this R. So with M we have 3, 5, 7 and 11, 3, 5, 7 and 11, and in R we'll just have 4, and of course they both share 9. And let's see what we have outside. So we have 3, 4, 5, we'll have 6 outside, we'll have 7, we'll have 8 outside, we'll have 10 outside, and those are the even numbers there apart from the square numbers. So 6, 4, 6, 8, 10, yes. Nice, and that should be our Venn diagram. Using a ruler, a pencil, and a pair of compasses, construct accurately a square ABC with sides 6 centimeters. Well, I don't have a compass set on this software, so what I will do is I will just sketch the image that you're supposed to get, and I will describe exactly what you're supposed to be doing. So first thing what we want to do is we want to make a little sketch in the corner here. So we know that we want a square A, B, C, D with 6 centimeters on either side. So the first thing I'm going to do is construct the base, and the base is a line construction of a line 6 centimeters long. So the first thing I'm going to do is draw a line that is much longer than 6 centimeters. Yeah, and then I'm going to mark off a point A. With my compass, I'm going to measure 6 centimeters, and then I will put the point on A and draw a mark there, and then that will be the point B. And I will also put my compass back here and draw an arc there just to make sure that I do indeed have 6 centimeters, and I will label it 6 centimeters, right? So the next thing I want to do is I will want to construct two 90-degree lines to give me C and D. So how I will do that is I will open my compass to any compass opening, right? And I will draw an arc on this side. From the point A, I will draw an arc on this side, and then I will draw another arc on this side. And with keeping the same openings, so I'll draw an arc on this side, and then I'll draw another arc on this side. Now I will put my arc point here, and I will open my compass to more past the length of A. And when it's past the length of A, then I will cut an arc like this, and that's from this being the center. And then over here now I will come and put the point here, and with the same compass opening I will put another one here, and it should cut like that. And you can see that from the point A to this point here, I will get 90 degrees. And what I'll do is I'll just draw a straight line going straight through, right, in order to get that. And I will repeat the process on this side. So from the point A, I will put a mark here and a mark here. Then I'll put my compass on this point, and I will open the compass to longer than A, and I will cut an arc across like that. And with the same opening from this point, I will cut an arc across like that. And then from B to this point here will be a straight line 90 degrees. Yeah. So I constructed my two sides, and now it's just to actually find the points D and C. We know that these sides are 6 centimeters. So what I will do is I will start from the point A, open my compass to 6 centimeters, and then cut an arc there, and I know that's the point D. I will come over here at the point B, and with the same 6 centimeters cut that arc there, and that gives me the point C. And now I could join the points D and C, right? And I will have my my square here, and this is a square where all of the sides are 6 centimeters. Make sure that just for safety's sake, you label everything, including all of your points. All of these things you will get marks for. You will get 1 mark. You see 3 marks there. 1 mark is for the lines that you draw, 1 mark is for your construction lines, and 1 mark is for your labeling. So you want to be able to get all of those marks, right? Construct as an extension of your drawing in B1 a trapezium so that the angle BAQ, so AB, DQ, a trapezium. So right now, what do I have? I have this here, and this is A, B, C, D, and I already have a whole bunch of construction marks here. Credit will be given for clearly drawn construction lines. Now when they say clearly drawn, please make a point that your construction lines need to be light. Really light. Even though they're clearly drawn, they need to be lighter than the actual drawing. So you want to make sure that the lines for this square here that you drew are darker than your construction lines, right? You do not want your construction lines to be too dark, especially because you do not want to have to erase a construction line, and next thing you know, it all messed up and messes up your page and all of that. So make sure your image is darker, and make sure your construction lines are lighter but still clear at the same time. So I want a trapezium where A, B, and Q is 120 degrees. So 120 degrees, A, B, and Q will be 120 degrees. A, B, Q. Right? And then we'll D. So I guess in that trapezium, I'll have A to B to Q, and then to D, and that will be the trapezium there, where this is 120 degrees. So let's go, and from the point P we have to construct 120 degrees. And how do we do that? Is we actually construct this 60-degree angle over here, and that will give us the 120 degrees on the other side, the supplementary angle. So we are actually going to construct a 60-degree from the point B, and I'll try to use a different color this time. Let's use purple. So from the point B, I'm opening my compass to any distance, and I'm going to cut an arc like that. And then with the same opening from this point, I'm gonna cut an arc to intersect like that. And then that will give me 60 degrees, and I will just draw this line all the way up past the square, right? Make sure I go all the way up there, right? So this here is going to be 60. That means that this guy is going to be 120 degrees. And all I really need to do is put my ruler from the point D to the point C and extend this line coming to meet here, and this is the point Q. And now I've done that, I have drawn a trapezium 120 degrees, added on to my original image, and hence measure and state the length of BQ. So the length of BQ here, well, I did not draw this I didn't draw this using any tools, so I would not be able to measure that. So I mean, you guys could just take your ruler and measure that line BQ. I think you all could do that. The construction is the hard part about this, right? Well, not really that hard. So we have a function question here. The function f is defined as the f of x is equal to a third x minus 2. Find the value of the f of 3 plus the f of negative 3. So I will find the f of 3 first, and that means that I just take 3 and I put it wherever x is, right? And that gives me, well, these will cancel off, so I'll have 1 minus 2 is minus 1 or negative 1. Then I have the f of negative 3 will give me a third, and I'll put negative 3 where x is minus 2. So these will cancel, I'll actually have negative 1. So this negative 1 minus 2 will give me negative 3. And therefore, notice the statements that I'm putting. I'm being very clear about what I am doing. I'm not just working all over the place. Is negative 1, that is the f of 3, plus the f of negative 3 gives me negative 3, which is negative 1 minus 3, which is negative 4. Calculate the value of x for which f of x is 5. So if f of x is equal to 5, that means that I'll have 5 on this side of the equation, because that's what f of x is, right? So a third x minus 2 is equal to 5. So if f of x equals 5 would imply that a third x minus 2 is equal to 5. Remember, I could throw this x across, sorry, the 2 across to get 2 plus 5. But remember, a third x is actually the same as x on 3. So x on 3 is equal to 7. And now I will have x being 7 times 3 when I throw the 3 across. So 7 times 3, and x will be 21. Determine the inverse of the function x. So f of x is equal to a third x minus 2. Is that it? Yes, it is a third x minus 2. So we could say that y is equal to, instead of putting a third x, I'm just going to put x on 3 minus 2. And now we'll make x the subject to the formula. So x on 3 minus 2 is equal to y. So x on 3 is equal to y plus 2. And we actually kind of just did this before, right? So x is equal to y plus 2 divided by 3. And this here is the exact same thing that we did in this question, where we made x the subject to the formula. So therefore, we interchange the x and the y. So y is equal to x plus 2 all over 3. And that means that f inverse x, the inverse of the function, is x plus 2 all over 3. The graph below shows two straight lines. Coordinate geometry now. We have L1 intercepts the y-axis at 0, 1. So let's see, L1 intercepts the y-axis at 0, 1, yes. You notice I'm not reading the entire question. I'm reading it in pieces, right? And line L2 intercepts the x-axis. The x and y-axes are those respectively. So we can see here the y-axis at 0, 6, and the x-axis at 12, 0 for L2, right, respectively. Calculate the gradients of both lines. So what do I know about gradients? So first of all, the graph shows respectively, right? What do I know about gradient? Well, I know I have a formula for gradient. So m is equal to y2 minus y1 all over x2 minus x1. So I need 2 points, right? So for L2, I have 2 points already. And the 2 points I have for L2 are 0, 6 and 12, 0. Those are the 2 points I have for L2. So therefore M2, let's call M2 the gradient for L2, right? So I'll have y2, which is 0, minus y1, which is 6, all over x2, which is 12, minus 0. So I'll have negative 6 all over 12. So we have here negative a half. And we could definitely see that this negative gradient here is for the line L2 sloping in this direction. We could also see that L1 is going to have a positive gradient as well. So for L1 now, we have 1 point, and that point is the point 0, 1. And we need another point. We don't have 2 points for L1, but thankfully we have a graph here, so we could actually find another point for L1. And we could see here, have a couple of points that we could use. But look where the 2 lines intersect. At that point 2, 5. That point is actually on this line L1, isn't it? It's on both lines, yeah. But we could definitely use that point as well. So let's use the point 2, 5. And if you didn't use 2, 5, that's fine. You would have gotten the same answer because you could have also used all of these points here from the line L1. So there are lots of choices you could have used. So now what do we have? We have M1 being y2, 5, minus y1, which is 1, all over x2, which is 2 minus x1, which is 0. So now what do I have? 5 minus 1 is 4, all over 2, and we get 2. Now I'm noticing something about these two guys, Alright, if you would notice, those two guys there tells me that L1 and L2 are perpendicular. So I am expecting the question to ask me that later down the line because they are perpendicular, right? Determine the equation of L1. Well, I have a point on L1, so L1 implies the gradient M1, which is 2, and then I have 1 point, which is, let's use the point that they gave us in the question, 0, 1, right? Yes, 0, 1. So I have that point 0, 1. And I could tell that C is from the point 0, 1. Remember, C is the intercept on the y-axis, and that's when x is 0. So I could tell that C is immediately going to be 1. Yeah? So C is going to be 1. So therefore, equation of L1 implies y is equal to mx plus C. And that is the equation of L1. Right? What is the relationship between L1 and L2? Give reasons for your answers. So the reason is that L1 and L2 are perpendicular, and the reason being because M1 multiplied by M2 is equal to negative a half multiplied by 2. If you multiply both of the gradients of perpendicular lines, you will always get negative 1. So once the lines are perpendicular and you multiply their gradients, you will get negative 1. That is the rule, right? All right, so not drawn to scale, we have here a quadrilateral, right? And we can see that Q is a point on PT where QT is equal to QR is equal to PT. So we can see those equal marks there. So those lines are equal, and that's important, right? That also tells us that this is an isosceles triangle, and that tells us that this is also going to be 76 degrees because that's the base of the isosceles triangle, right? So you can see I didn't even read the question yet, the entire question. I'm already forming conclusions, right? And of course they tell us that that angle there is 76. So determine, giving reason for each step of your answer, the measure of the angle RQT, RQT. So RQT will be, well, we could say that triangle RQT is isosceles. So therefore, we could say that 180 minus 76 times 2 will give me the that angle there. So that gives me 28 degrees, about so. So therefore angle RQT is 28 degrees. Angle PRT. So that's PRT, that's this angle here. So I know that this is 28. So that means that this will have to be 180 minus 28, which is 152. And if these two are the same, then that means that this is also an isosceles triangle, PRQ, even though it doesn't look like it. So therefore this angle here would be equal, like this angle here would be equal to this angle here. So let's call this angle X, right? So therefore we could say that 180 is equal to 152 plus 2x, right? So now we can actually find what that angle is. So let's work it out, right? 152 plus 2x is equal to 180, right? So x is going to be 180 minus 152 divided by 2. So that'll give us 28 divided by 2 is 14 degrees. What? No, that doesn't sound right. Yeah, it is. So if x is 14 degrees, therefore, and we have to give reason for this, right? So the reason here being that the triangle PRT is isosceles, therefore angle Q, the angle at Q is 152 degrees, right? So this here, what we just found is the angle PRQ. So this here is angle PRQ. So therefore PRT is equal to PRQ 14 degrees plus the 76 degrees. And I believe that gives us, yep, it does, 90 degrees. Angle SPT, given that the angle SRT is 145 degrees, so let's write that information in first. The angle SRT, right? So this entire angle here, angle SRT, is 145 degrees. Is that what they're saying? Yeah. And angle PSR, this angle here, is 100 degrees. So we can see here that we have a quadrilateral, right? And we know that in quadrilaterals, the opposite angles are supplementary. The opposite angles add up to 180 degrees. So what is the angle they want us to find? SPT. SPT is this angle here. So that means that it'll be supplementary to 145. So therefore, SPT will be 180 minus 145 degrees, which is about 35 degrees, and SPT, because angles, or I should say opposite angles, in quadrilaterals are supplementary. And you guys please make a greater effort to write neatly. Yeah, don't be like me and be writing scrappy like that. I'll make a greater effort to write neatly too. The diagram below shows triangle ABC and its image A prime, B prime, C prime under a single transformation. So ABC and A prime, B prime, C prime under a single transformation, right? Completely describes the transformation, right? Now at the end of the day, a single transformation, I mean, in order to get this to this, I would probably need to rotate this and then translate it. So it's not going to be a translation or a rotation, but maybe it is a rotation. Let's see. If I have B mapping on to B prime, that means that this could be the center of rotation there, and I would have to rotate 180 degrees, right? If I have A mapping to A prime, and let's just say that this here, we're saying that this is the center of rotation. Okay, that's definitely not 180 degrees. That A is swinging all the way. So if it was 180 degrees, then A would have been here. So 180 degrees, if it were 180 degrees about here, we would have had B prime here, but we would have had A prime here. And then we would have had C prime here. Alright, so that would have been 180 degrees. So let's try something else. If we go this way, so we could see that A will rotate this way to get here. We will see that C rotates this way to get there, and we will see that B will rotate this way to get here. But how will that rotation? Well, maybe the center of rotation isn't here. Maybe the center of rotation would be here, and now B could rotate like that and reach there. And if I had the center of rotation on the origin, A could rotate like that and reach there. And we could see that this rotation for B looks like 90. The rotation for A looks like 90. Yeah. And if we look at C from the center, from the origin, that looks like 90. So I could say here now that from the origin being the center, we rotated this 90 degrees clockwise. So a rotation 90 degrees clockwise about the center origin 0, 0. Translation vector 4, -5 maps a prime to a double prime, triangle prime to double prime. On the diagram below, draw the double primes, right? So 4, -5 is t. So t is equal to 4, -5, right? So what we're doing is we're taking this prime and we're mapping it to the double prime. So what will I have? I will have A going 1, 2, 3, 4 spaces there, horizontal, and then 1, 2, 3, 4, 5. So this is going to be A double prime. So that means that this is going to be B double prime, and this is going to be C double prime, and that is what our translation will look like. In this problem, pi is taken to be 22/7. The diagram below, not drawn to scale, shows a field, the shape of a sector. Of a circle with center O and diameter 28. So the diameter, so that means that this full diameter is going to be 28. So that means that here is going to be 14 meters, and this is going to be 14 meters. The angle POZ is 90 degrees, so we have 90 degrees over here. What is the area of the field? Well, the area of the field will be the area of the circle, the full circle, so that's pi r squared, multiply by the fraction of the angle that we have. So the fraction of the circle we're dealing with is 90 over a full 360. Yeah, so what do we have? We have pi r, which is 14 squared, multiplied by 9 on 36. So then that means that we have 14 squared being 196. So we have 9 on 36 is a quarter, 14 squared is 196, and then we have pi. And you notice I'm not doing the decimal thing with pi. I'm leaving my answer in terms of pi because, they say here in this problem, take pi to be 22/7. Okay, good. So I will do the pi thing after, or maybe I could do it now. So where's 96 over 1? 96 over 4 is 49. So that means that 49 is being multiplied by 22/7. So that means that the answer will end up being 154 meters squared. So that's the area of the field, right? The perimeter of the field, well, we have 14 and 14, but we need to find what is this. And of course, that is part of the circumference of the circle. So the arc PZ, we first need to find the arc PZ, and that is really the circumference of the circle, which is 2 pi r multiplied by the fraction of that part of the circle. Right? So we're taking the entire circumference of the circle and multiplying it by the fraction of that particular circumference that we're looking for. So we could see here that we will have, this is a quarter, and 2 times 14 is 28 pi. So we will now have here 7 pi, which is 22/7. So therefore the arc is 22 meters. So therefore the perimeter will be the 22 plus the 14 plus the 14, and that gives us 50 meters about. The diagram below, not drawn to scale, shows a triangular prism ABCDEF. The cross section is a right angle triangle ABC, where AB is 6 centimeters and BC is 10 centimeters. We can see all of the information on the diagram there. The area of the triangle ABC will be a half the base times the perpendicular height, but I do not have the perpendicular height, but I can find the perpendicular height using Pythagoras theorem. So I will actually put and I should make clearer statements like that. Area equal a half base by the perpendicular height, and I don't have this, but I could use it using Pythagoras. Implies that the hypotenuse squared is equal to the 6 squared plus the height squared. So therefore the height squared is equal to the 10 squared minus the 6 squared, because it's the 6 that I'll be throwing across to become minus 6. And so therefore h is equal to the square root of 10 squared minus 6 squared. So that will be, I have 10 squared, which is 100, minus 6 squared, and the answer is 64. So the square root of 64 is 8. So we have h is 8 centimeters. So therefore the area of ABC is equal to a half the base, which is 6, times the perpendicular height, which is 6/8 of 48 divided by 2 is 24 centimeters squared. Please remember your units, and as I said that, I'll remember mine. The length of the prism, if the volume of the prism is that. So we know that if we take the area of this and we multiply it by the length L, we will get the volume. So volume is equal to area times height, or in this case length, right? So we want to know what's the length. If the volume is 540 and the area of that base there is 24, what is the length? So therefore the length is 540 divided by 24, which gives us about 22.5. The surface area of the prism. Oh my goodness, that is quite a thing. So we have the area of this triangle here. So the area of this triangle here, what do we found that to be? We found that to be 24 centimeters. So this area is 24. So that means that this is 24 centimeters squared. This here is 22.5 cm. That means that this is going to be 22.5 cm. Okay? So the area of this base here, just this base part here, will be 6 times 22.5. So 6 times 22.5 is 135. So this is 135. Alright, so we have 24, 24, 135. The area of the back, this back face over here, is going to be 22.5 times 10, which is 205 centimeters squared. And then that is going to be the same as this area of this face here, which will be the 22.5 times 10, which is 225 centimeters squared. So we could have here, so the area the full surface area is equal to, we will have 225 plus 225 plus 24. All right, so 225 times 2. So 225 times 2 plus 24 times 2 plus 135. So 225 times 2, 24 times 2, and then 135 at the base. And that gives us 225 times 2 is 450 plus 48 plus 135, and that will give us 633 centimeters squared, and that is the full surface area. Statistics now. The table shows the speeds to the nearest kilometer hour of 90 vehicles that pass a checkpoint. Frequency, cumulative frequency. I need to eat food, so let's take a break. Alright, so we have this question here. The table below, and we're in statistics now, so the table below shows to the nearest kilometers per hour of 90 vehicles that pass a checkpoint. So they gave us a total amount of vehicles there, 90. So if we add up all of our cumulative frequency numbers, we should end up with 90 as a total there, right? So we see the amount of cars that go on between a certain times and speed. So for the class interval 20 to 39, as written in your table above, complete the following sentences. The upper class limit for this particular class will be 39.5. The class width will be the 39.5 minus the lower class limit, which would be 19.5. And that gives us an even 20. 16 vehicles passed a checkpoint at no more than 16 vehicles, so 16 and under, passed the checkpoint at no more than 39 kilometers per hour. 0.5 kilometers per hour. Complete the table shown above by inserting the missing values for the cumulative frequency column. So 11 plus 5 is 16, 26 plus 16 is 42, 42 plus 37 is 79, 79 plus 9 is 88, and 88 plus 2 gives us the full 90, right? So on our graph provided, use the scale 2 centimeters to represent 20 kilometers on the x-axis. So 2 centimeters to represent 20. So from 0, I'll go 20, 40, 60, 80, 100 kilometers. Oh, and I'll need up to 120. So I'll put 120 over here. And then 2 centimeters to represent 10 vehicles on the y-axis. So 2 centimeters to represent 10, 20, 30, 40, 50, 60, 70, 80, and 90. And of course, this is my y-axis. Alright, so this is frequency F. This here is the x-axis, kilometers per hour. On your graph, draw the cumulative frequency curve to represent the information on the table, okay? So what I'll do is I will just plot my cumulative frequency against the upper class limit. So I'll go with 20 here, I'll go with 40 here, I'll go with 60 here, I'll go with 80 here, I'll go with 100 here, and I'll go with about 120 over here. So 1939 actually. Alright, so I will just plot this cumulative frequency to the upper class limit, 19, 39, 59, 79. So I have 5, 16, 42, 79. So 5 goes on 19. 16, 42, 79, 88 and 90. So I'll have here 88. And then I'll have here 90. So we can see we have a cumulative frequency curve. It's a bit weird. Actually, this here is this point that given me pause. So this point here is supposed to be 79 about here. Alright, so this makes more sense. So we have a cumulative frequency curve, and let's try to draw this curve as smoothly as possible. So we're starting from 0 here. So we have our cumulative frequency curve, and now let's see some of the other questions. On your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove past the checkpoint. So 50% of the vehicles. So I have 90. So on the graph, draw a reference line. So this mark is just for the reference line to show no more than 50% of the vehicles. So 50% of the vehicles would be 45 vehicles. If it was 90 vehicles, 50% would be 45. So the reference would come about so. And let's say it meets that point, so it will go down there. And we can see that that is a speed of about 59 or 60, depending on how accurately you draw your graph. So what is the estimated speed? Let's just say it's approximately 60 kilometers per hour there. Right, so we have a sequence question now. The first four figures shown below. Figure 1 is a single black dot, as we can see, while each of the others consist of black dots arranged in an equilateral manner. So we can see here 1 in the base, 2 in the base, 3 in the base, 4 in the base. So the next figure will have 5 in the base, 2, 3, 4, 5. So that means that it'll look like this. And that should be your next figure there. How many dots would be in figure 6? Interesting. So we just saw figure 5, and figure 5 had 5, 4, 3, 2, 1. So figure 6 would probably have 6 plus 5 plus 4 plus 3 plus 2 plus 1. So that'll be 21 dots. Right, so we could see here figure 5 had 5, 4, 3, 2, 1. Right, so 5 plus 4 plus 3 plus 2 plus 1. So figure 6 would have just had 4, 5, 6 plus 5 plus 4 plus 3 plus 2 plus 1. Right? So over here now we could see that we have the number of dots D in terms of n, and then we just have the number of dots D used, right? So we could see here that we have this is n, this is n. So this is n, this is n, because you can see the n here. So whatever n is, we multiply it by a half, and then we have n plus 1. So I could safely say that this is a half times n times n plus 1. Right? A half times n plus 1. So that looks pretty good. So in this case here, when n is 11, I'll have a half times 11 plus 1. And so over here now, we will have the number of dots used being about 66. Then of course over here will be a half n into n plus 1. Okay, so determine which figure in the sequence has 210 dots. So we now have a half n into n plus 1. So which n will have 210 dots? So what I'm looking for is I'm looking for one number that when you multiply a number by the one right after it, you get 420. So we could try 20 by 21, because 20 by 20 is 400. So therefore 20 by 21 will give me 420. And so I didn't really need to expand it out. I could just use logic, and I could see that n is going to be 20. Write a simplified algebraic expression for the number of dots D. So the number of dots is a half n into n plus 1. A simplified algebraic expression means that I would have to expand this out. So that would give me a half n squared plus a half n. Okay. So show that there is no diagram that has exactly 1,000 dots. So if a diagram had 1,000 dots, then that nth diagram, which is described by this, would be equal to 1,000 dots. So it looks like we have a quadratic here that we need to solve, right? So let me just zoom in. And I will go a little bit smaller. So in solving this quadratic, I could see that if I multiply throughout by 2, it would get rid of these pesky halves. So I would now have n squared plus n is equal to 2,000. And so I could have n squared plus n minus 2,000 is equal to 0. Right? And from here I could try to factorize. Now remember, when we factorize them, we're looking for two numbers that when you add them you'll get 1, but when you multiply them you'll get 2,000, or negative 2,000 actually. So two numbers that when you add them we will get positive 1, and when we multiply them we will get negative 2,000. Oh my goodness. Well, you know, I am not really sure. mean, you know, when you add them, 2000, so maybe it, yeah, it could probably be 20 and 21, right? No. 5 and 4, maybe. So I'm stumped by this. So I'm just going to go in my working column, and I am going to use my quadratic formula. So so minus b, which is minus and positive 1, plus or minus the square root of b squared minus 4a negative 2000 is c all over 2a. So what do we have here? Negative 1 plus or minus the square root of 1 plus 4 2s are 8000 all over 2, which gives us minus 1 plus or minus the square root of 8001 all over 2, which gives us the square root of 8001 is a decimal, a rather annoying decimal. So plus 1 or minus 1 divided by 2. So we're getting about 44.2 there, and we're seeing that this is not a whole number, so therefore it will not have an actual diagram with 1000 dots. Is not a whole number. So there will be no n value for that'll give you 1000, or no whole number n. And of course, the number of diagrams could only be expressed in whole number. So in section 2 now, we have a velocity time graph below. Shows the motion of a cyclist over a period of 40 seconds. So I can see the 0 to 40 seconds here. And this is 10 up there. So calculate the gradient of OA. So OA in terms of gradient, we could do y2 minus y1 and all of that madness, but remember we could just do vertical rise over the horizontal shift, rise over run, right? So the vertical rise of OA, so OA lasts from here to here, so that vertical rise will be 10 all over the horizontal run, which is 25. So that'll give us 2 over 5. Positive 2 over 5. And of course, remember that we are in a velocity time graph, so that gradient there is actually giving us the acceleration or the change of velocity. So that'll be meters per second squared, right? Now A over AB, so the point AB, as you can see, is a flat line, and that has a gradient of 0. So AB gradient is 0. Complete the following statements. The cyclist started running from rest where his velocity was, well, if he's running from rest, his velocity is 0, right? And let's try to put 0. And steadily increase his velocity by 2/5 meter per second. Each second is meter per second squared. So 2/5 meter for the first 25 seconds. During the next 15 seconds, and that is his acceleration was 0, right? If the velocity is constant, you have no acceleration, so that is a gradient. Determine the average speed of the cyclist over the 40-second period. So the speed is generally distance moved over time taken. The average speed though, okay, so the average speed, we want to find the average speed, right? And we have to know that in a velocity time graph, we have average speed, and speed is distance over time. The problem is that we have a velocity time graph. It's not a distance time graph, so we do have distance, but we can get distance from a velocity time graph, and the distance will be the area under the graph. So we have this area here, and we can see that this area here will boil down to being 5, 10, 15 times 10. And then this area here, the area under the triangle, will be a half the base, which is 25, times the perpendicular height, which is 10. So that means that the distance he travels under the triangle will be a half of 25 times 10, and that is 125 meters. And then over here, 15 times 10 is 150 meters. And so the distance that he traveled would have been 125 plus 150 is 275, right? So the total distance traveled is 275 meters. So therefore the speed, or the average speed that he used, would have been the 275, which is the distance all over the time taken, which was 40 seconds, I believe. So 275 divided by 40 gives us approximately 6.875 speed meters per second. Consider the following pair of simultaneous equations without, they say without solving, show that 1, 2 is a solution for the pair of simultaneous equations. Well, if 1, 2 is a solution, that means that that point will work for both equations. So at 1, 2 implies we have x plus y equal 3. X is 1 plus y is 2 is equal to 3. Yes. And then at 1, 2 again, we have x squared plus 2xy equals to 5. So therefore x, which is 1 squared, plus 2 times 1 times 2, and that is equal to 5. Yes. So without solving, show that 1, 2 is a solution. So therefore 1, 2 is a solution. Solve the pair of simultaneous equations above to determine the other solution. Okay, so now we have to do the simultaneous equation thing. So let's write x squared plus 2xy equals 5. So x squared plus 2xy equals 5. And then the other one I have x plus y equals 3, I believe, right? So let's call this equation 1, let's call this equation 2. And from equation 2, we could get, if we want to substitute for y first, y is equal to 3 minus x. Doesn't really matter which one we did first. In 1, so now I will get x squared plus 2x times 3 minus x is equal to 5. X squared plus 2 3s are 6x minus 2x is equal to 5. So x squared, 6 minus 2 is 4x, and I'll bring the 5 across here, is equal to 0. And now we could factorize this. We already know one of the factors for x is going to be 1. So what do we have to do to get negative 5 and positive 4? The two numbers, if we add them, we will get positive 4. And if we multiply them, we will get negative 5. So that could only be 5 minus 1. 5 minus 1 is positive 4. So I'll have a 5 on this side. I'll have a negative 1 on this side. Okay. And that means that I have x plus 5 and x minus 1. So therefore we have x is equal to 1, which we saw before, and x is equal to negative 5. So when x is negative 5, and I'll just draw this little. Alright, so we'll take when x is equal to 5, and we have here y is equal to 3 minus x. So y is equal to 3 minus negative 5, which is 3 plus 5, which gives us 8. So therefore the solutions are 1, 2, and negative 5, 8. We have circle theory here. P, Q, R, S are 4 points in the circumference of the circle shown below. We can see 58 degrees at the point R there. Angle R. Using geometrical properties of a circle, give reasons for your answer. For each step, determine the angle SPQ. So SPQ is here, and SPQ is bound by the very same chord that binds this angle at O and this angle here that subtends that angle there. We can also see that this figure here is a cyclic quadrilateral, and we know that the opposite angles of a cyclic quadrilateral are supplementary. So that means that that is equal to 180 minus 58, which is 122 degrees, because opposite angles of a cyclic quadrilateral are supplementary. OQS. So I want the angle. So what do I get? What did I get here? 122. So 122 is here. OQS. So OQS is this angle over here. All right. You see it's 3 marks, so it may be a little bit more. I could tell here that these are radii from the center O. So that means that these guys are indeed equal. And because these guys are equal, it's an isosceles, which means this is the same as this. I could also tell that the angle at O is going to be 58 times 2. So 58 times 2 is 116. So this is going to be 116 here. And of course, in an isosceles triangle, we will have 180 degrees being equal to, let's call this x. So I have 2x plus 116, and now we could find what that is, right? So let's say that the angle of O, the angle at O is 116 degrees. Angle O is equal to 116 degrees because angles at the center are twice angles at the circumference. Yes, you do have to write all of this out. Subtended by the same chord. And now we could see that the triangle OQS is an isosceles. Therefore, 180 degrees is equal to 2x plus 116. Now we could find out what that is, so therefore the angle that we're looking for will actually be 180 minus 116 divided by 2, which is 32 degrees. Therefore, angle OQS equals 32 degrees. So that means that these tiny little angles here are 32 each. Alright, and now we are here. A ship leaves the port A and sails 52 kilometers on a bearing of 44 degrees to port B. I could see that. Let's see. A ship leaves A and sails 52 kilometers. So from the north line, this is 44 degrees, and this is 52 kilometers, right, to the port B. And then the ship changes course to sail 72 kilometers away to port C. So this is 72 kilometers on a bearing of, from the north line, 105 degrees. Right? On the diagram below, not drawn to scale, label the distances traveled and the known angles. Well, we just did that. Distances and known angles, right? Determine the measure of angle ABC. And we actually did this question in class already. So the angle ABC is this angle over here. ABC. And we can tell that we have these knot lines are actually parallel. So if these knot lines are parallel, that means that this angle and this angle here are co-interior angles which add up to 180 degrees. So 180 minus 44 means that this angle here is 136 degrees. And so this angle here being angles around a point, right? So therefore, angle ABC is equal to 360 degrees, angles around a point, minus the 136 plus 105. So that'll give us 136 plus 105 equals that, 241, and 360 minus 241 gives us 119 degrees, right? Calculate to the nearest kilometer the distance AC. So I got this angle here being 119 degrees, and I want the distance AC. So the distance AC is this distance here. And what do I notice is I have the two sides and the angle in between. So that tells me maybe that the cosine rule might help me. So this is the side B, and I'll write small b. This will be the side C, and this will be the side A. So B squared is equal to A squared plus C squared minus 2AC cos of B. So let's just remember that. And I'll do it on this side here. So that means that B squared is going to be equal to A squared, which is 52 squared plus, well, 72 plus 52, doesn't really matter, minus 2 into A, 72 times 52, the cos of 119 degrees. Be very careful with all of this. This will really test how you use your calculator. I would find 52 squared plus 72 squared first, and that would give me 7888 minus, and now I would find that, and how I'd find that is I would actually type in the cos of 119 first, and that is a negative, and I'll actually multiply that by 2 times 72 times 52, and that is equal to, and because this is a negative, means that the negative and a negative gives me a positive, so that'll be positive 3630.25. so therefore B is equal to the square root of, when I add these two, we'll get about 11518.25, and so B is the square root of the answer, about 107.3 kilometers. And that looks about correct. Show that the bearing from A from C to the nearest degree is 260 degrees. Right? The bearing of A from C. So let me just take this and put it aside. I'll put this down by where it should be. Right, so what do I want? I want the bearing of A from C. So that means that I want from C, I have to measure that from the north line all the way here, because you're going in this direction towards A. So the bearing of A from C, and at the end of the day we have to show that this is what, 260 degrees. Well, if this is 260 degrees, remember these knot lines are parallel, so that means that this angle here is going to be 180 minus 105 is 75, right? And therefore, if this is 75, we can't use this 260 here. We cannot use that. So we can't use that to find this little angle. So now we have to find this little angle here. And in order to find this little angle there, we could use the sine rule, because we have C over the sine of C, and we have this, we have that 107.3 kilometers here. So this is 107.3. So we could say that C over the sine C, so is equal to, this is B over the sine B. Right? And what do we want? We actually want this. So that means that I'll have to cross multiply. So B sine C is equal to C sine B. And therefore sine C is equal to C sine B all over B. So that is C, which is 52, times the sine of 119 all over 107.5. So therefore sine of C is equal to, I'll type the sine of 119 first, then I'll multiply that by 52, and then I'll divide that by 107, and then I'll find the sine inverse of that. So the sine inverse of the answer gives me C to be the angle at C is about 25.15 degrees. So this here is 25 degrees, approximately 25 degrees. So 75 plus 25 is equal to 100. So that means that this here will be 360 minus 100, which is 260 degrees. Nice question, right? So So vectors and matrices, the vectors A, B, the vectors A, B are such that that's A and that's B. Show by multiplying A and B that A, B does not equal to B, A. So we have to show that matrix multiplication is not commutative. So AB is equal to 3, 2, 5, 4. And you had to learn how to do these matrix multiplications quickly but carefully at the same time. So that is going to be equal to 3 4 3s are 12, 2 3s are 6, 3 times 0 is 0, plus 2 times negative 1 is negative 2. Yeah. 5 4s are 20, 4 3s are 12, 5 times 0 is 0, 4 times negative 1 is negative 4. So 12 and 6 is, I'm going to get 18, negative 2, 32, and negative 4. This is the matrix AB. Now let's check out the matrix BA. So I'm going to write B, 4, 0, 3, negative 1. And the matrix A is 3, 2, 5, 4. We do the matrix multiplication. 4 3s are 12 plus 0, and we can obviously see here we're going to start to get something different. 4 2s are 8 plus 0 times 4. 3 3s are 9 plus 5 negative 5, 5 times 1, and 3 2s are 6 plus negative 4. And what do we get? We get 12, 8, 9 minus 5 is 4, 6 minus 4 is 2, so very different. Therefore, AB does not equal A. Please make sure and make these final statements, right? Find A inverse, the inverse of A. So let's write over A first. A is 3, 2, 5, 4. So we know that A is equal to 3, 2, 5, 4. And what do I need to find A inverse? I need the determinant of A, which is 4 times 3, 4 3s are 12, minus 5 2s are 10, which is 2. And then the adjoint, which is a flip that, so 4 and 3, and then I put negative 5 and negative 2 there. So that is the adjoint. So now A inverse is equal to 1 all over the determinant multiplied by A adjoint. And please make these statements so that the examiner will know what you're doing. So we have 1 all over the determinant multiplied by 4, negative 2, negative 5, and 3. And we can actually leave it like that. We don't have to, because you see this a half here, if I multiply it throughout, I'll end up getting 5 over 2 and 3 over 2, and that just looks ugly. So we can actually just kind of leave it like this. This here is the inverse of B. Write down the 2 by 2 matrix representing the matrix product A times A inverse. 1 mark. A times A inverse would normally give you I, which is the multiplication identity. Anything times its inverse gives you the identity, right? Write the following pairs of simultaneous equations in matrix form. Do we have to solve them? Write the solution of the matrix in B1. Yes, so we do have to solve these simultaneously. So this would be 3, 2, 5, 4 times xy is equal to 1, 5. Right? And we can see here that this is 3, 2, 5, 4. 3, 2, 5, 4. This is the matrix A. So we already have A inverse here that we're going to use. Right? So therefore, xy, to find the solution, xy will be, and let's just put here, is of the form a times x equals b. Therefore, x is equal to a inverse times b. And so we have here a inverse times b. So that is a inverse being a half into the matrix of a inverse, which was a half, 4, -2, -5, 3. 4, -2, -5, 3 times b. Well, I shouldn't really call it b, but I'll just call this one b. 1 over 5. There's already a matrix b in the question, so we don't want to mix them up. This b that we're talking about here is the matrix 1, 5. And now I could do this multiplication here, right? So 4 1s are 4, plus 5 2s are 10, -10. And 5 1s are -5, plus 5 3s are 15. Remember, we have the half on the outside here, so that'll give us a half into 4. 4 minus 10 is -6, and 10. So that means that if I multiply the half throughout, I will get -3, and I will get 5. So therefore, x equals -3, and y equals 5. Vectors. The position vectors of points P and Q relative to an origin O are that. And you can see here that they both come from the origin. And I believe we did do this question in class already, right? The diagram below shows PR being 3 times OP. So PR here, this is 3 OP. Yeah? So 3 times OP. So 1, 2, 3, and OP here, this is 4. So this is a section with 4 OPs in it, right? PR being 3 times OP. And then QS is 3 times OQ. So this is 3 times OQ. So 1, 2, 3. So you can see I have 4 OQs here in total, expressed in the form xy, the vector OS. So let's write OP is 4, 3 over here, and OQ is 5, 0 over here. What do we want? We want the vector O to S. Where is S? Oh, O to S. So O here and S here. Right? So you can see O to S is 4 times OQ. So OS is equal to 4 OQ, which is 4 times 5, 0, which is 20. PQ. So P to Q is this direction here. And I would go PO plus OQ. So PQ is equal to PO plus OQ. So PO is -43. Plus OQ, which is 5, 0. So I have now 5 minus 4 is 1. And 0 minus 3 is minus 3. So 1 negative 3 is PQ. RS. R to S is here. So in order to get from R to S, I could go RO plus OS. right? So RS is equal to RO plus OS. RO is 4 times OP. And remember that's negative. So RO is negative 4 times OP. Because we can see here we're going in the opposite direction. OP goes this way. So negative 4 times OP. Right, so RO is negative 4 into 4, 3. So RO is negative 4 into 4, 3. Plus OS, we already saw that that is 1, 2, 3, 4. And we have OS here, 4, well 20, 0, we could use 20, 0. So let's just expand this out. 4 4s are negative 16 and 4 3s are negative 12 plus 20, 0. And that gives us 20 minus 16 is 4, and that is negative 12 there. State two geometric relationships between PQ and RS. PQ and RS. So that is those two there. So let's see what PQ is. 1, negative 3, and 4, negative 12. So PQ is 1, negative 3, and RS is what? 4, negative 12. So we could see here that if we pull out 3 from here, no, if we put 4 in front of here, then we will have RS. So RS is actually 4 times PQ, right? So since RS is 4 times PQ, we could state that they say two geometrical relationships. One, they are scalar multiples, and therefore two, they are parallel. Once they're scalar multiples of each other means they're parallel, and that is the end of the test. So this was June 2017. I hope you guys did well, and I'll see you all in class.